Three of the most powerful technology companies on the planet just formed an alliance that almost nobody saw coming, and the implications of what they have built together are going to affect every iPhone you use, every Siri query you ask, and the entire direction of how AI gets delivered to billions of people around the world. Apple, Google, and Nvidia have joined forces to power the next generation of Apple intelligence, and the details of exactly how this partnership works and why Apple decided to do it this way reveal something genuinely important about where the AI industry is heading in 2026. This is not a simple partnership announcement. This is a fundamental restructuring of how one of the world's most valuable companies approaches artificial intelligence, and it tells a story that goes far beyond Apple. To understand why this partnership is such a big deal, you first need to understand what Apple tried to do before turning to Google and Nvidia for help. Apple's original approach to cloud AI processing was something they called private cloud compute, a proprietary infrastructure system that Apple built and operated entirely on their own hardware using their own Apple silicon chips in their own data centers. The idea was classic Apple: control the entire stack, from the silicon to the software to the servers, and in doing so deliver both the best possible performance and the strongest possible privacy guarantees to users. Private cloud compute was Apple's attempt to build a cloud AI infrastructure that was as tightly integrated and as trustworthy as the on-device experience they have always been famous for. It was a bold and ambitious vision. There was just one problem: it was not fast enough. According to reporting from The Information, Apple's own private cloud compute infrastructure proved too slow when processing the most complex and demanding AI queries that the next generation of Siri needed to handle. The models that Apple wanted to deploy for tasks requiring advanced reasoning, contextual understanding across a user's personal data, and the kind of conversational intelligence that makes a genuinely useful AI assistant were simply too computationally demanding for Apple's existing cloud infrastructure to handle at the response times that users expect from a voice assistant. When you ask Siri something and it takes 3 or 4 seconds to respond, the experience feels broken regardless of how accurate the answer is. Speed is not just a nice-to-have in AI assistants. It is a fundamental requirement that determines whether the technology feels useful or frustrating in real everyday use. The solution that Apple arrived at is one that reflects both pragmatism and the realities of where AI compute capability actually lives in 2026. Apple is routing complex Siri queries to Google Cloud, where those queries run on servers powered by Nvidia's Blackwell B200 chips. The same Blackwell architecture that powers Nvidia's data center AI accelerators and that has been driving the AI infrastructure boom we have been covering all year is now inside the cloud backend that processes your most demanding Siri requests. Apple is using a licensed version of Google's Gemini model specifically to train smaller versions of their own models that can run locally on Apple devices, a process known as model distillation. The top-tier model in Apple's third-generation Apple Foundation models family, called AFM Cloud Pro, actually runs on Nvidia GPUs inside Apple's expanded private cloud compute infrastructure, which has been extended into Google Cloud for this purpose. This is not Apple simply reselling Google's AI. It is a deeply technical collaboration where Google's infrastructure and Nvidia's hardware serve as the compute backbone for Apple's own AI models. The privacy angle of this partnership is the part that Apple has been most careful to explain clearly, because privacy is arguably the most important pillar of Apple's brand identity, and any arrangement that sends user data to external cloud infrastructure requires a convincing explanation. Apple's approach to maintaining privacy within this Google-Nvidia cloud partnership centers on a technology called confidential computing, which is a security feature built directly into Nvidia's GPU hardware. Nvidia's confidential computing capability encrypts both the user data and the AI model itself as they are being processed, which means that even the infrastructure operators, including Google and Nvidia, cannot access the content of what is being computed. Apple's CEO Craig Federighi explained at WWDC 2026 that the system uses what Apple calls a system orchestrator that routes every AI query to the appropriate processing location, either on the device itself or in the cloud, depending on the complexity and sensitivity of the request. Federighi described this orchestrator as key to the privacy architecture of our entire system, and Apple is betting that Nvidia's confidential computing hardware provides sufficient cryptographic protection to maintain their privacy commitments even when queries are processed on third-party infrastructure. The scale of Apple's investment in this Nvidia-powered Google Cloud infrastructure gives you a sense of how seriously the company is taking this partnership. Reports from earlier in 2026 suggested that Apple was in the process of purchasing approximately 250 Nvidia NVL72 server systems, with each of those systems costing around $4 million. That is roughly $1 billion in Nvidia hardware purchases for Apple's cloud AI backend alone, not counting the ongoing Google Cloud infrastructure costs. For a company that has historically prided itself on building and owning its own technology infrastructure, this level of reliance on external partners and external hardware is genuinely unusual and reflects just how decisive Nvidia's advantage in AI compute performance has become. When even Apple, with all of its engineering resources and silicon expertise, decides that Nvidia's Blackwell chips are the right hardware for their most demanding cloud AI workloads, it tells you something important about the state of the AI hardware market in 2026. The competitive implications of this three-way partnership are worth thinking through carefully from multiple angles. For Nvidia, having Apple as a cloud AI customer validates their Blackwell architecture at a level that goes beyond any benchmark or enterprise customer win. Apple's standards for performance, reliability, privacy, and quality are legendary in the industry, and Apple choosing Nvidia hardware for their most important AI infrastructure sends a signal to every other enterprise customer considering AI compute investments. If Nvidia's hardware is good enough for Apple's privacy-first, quality-obsessed approach to cloud AI, it is good enough for essentially any enterprise use case. For Google, the Apple partnership represents a remarkable commercial and reputational win. Google Cloud is now the infrastructure backbone for one of the most scrutinized and high-profile AI deployments in the world, providing Google's Gemini models and cloud infrastructure to power the AI system that will run on more than 1 billion active Apple devices. Google and Apple have been competitors and occasional collaborators for decades, but this partnership puts them in a more deeply intertwined relationship than they have ever had before. What does this partnership mean specifically for the Apple Intelligence features that users will actually experience? According to Apple's WWDC 2026 announcements and the technical details that Craig Federighi and Apple's AI lead Amar Subramanya shared in a tech talk after the keynote, Apple's system uses a hierarchy of 5 models within the third generation of Apple Foundation models. The 4 smaller models, called AFM Core Advanced, AFM Cloud, and AFM Cloud Image, were trained entirely for Apple Silicon and run either on the device itself or on Apple's existing cloud servers using Apple chips. Only the top-tier model, AFM Cloud Pro, actually runs on the Nvidia GPU-powered Google Cloud infrastructure. This top-tier model handles the most complex and demanding queries that require frontier-level AI reasoning capabilities, and Apple says its quality is comparable to Google's own Gemini frontier models. Federighi was careful to clarify that Apple is not using the Gemini app, the models Google ships to its own customers, or Google Search as a knowledge base. The Gemini technology that Apple uses was specifically licensed and adapted for Apple's purposes rather than being the same product available to Google's own customers. The hardware reality that drove Apple to Nvidia is worth understanding in its broader context because it reflects a challenge that every major technology company building cloud AI services is navigating right now. Building custom AI silicon in-house. As Apple has done brilliantly for mobile devices with their M-series and A-series chips, is extraordinarily difficult when the target workload is frontier-scale large language model inference in a cloud data center environment. The engineering challenge of designing a chip that can efficiently run models with hundreds of billions of parameters, serve millions of simultaneous requests with low latency, and do so within the power and thermal constraints of a data center rack is genuinely different from designing a mobile processor. Nvidia has spent years and billions of dollars solving exactly that problem, and the result is a hardware and software stack optimized for precisely the workloads that Apple needed. Rather than spending 5 or more years trying to build a comparable custom solution, Apple made the pragmatic decision to use the best available tool for the job and focus their custom silicon efforts on the on-device AI experience where Apple Silicon genuinely leads the industry. The direction this three-way partnership points toward for the future of AI delivery is perhaps its most important implication. The Apple model of using sophisticated on-device processing for routine and privacy-sensitive tasks combined with cloud AI for the most demanding and complex queries is a template that other technology companies are likely to study and adapt. The combination of privacy-preserving on-device intelligence with cloud AI supercharged by Nvidia's hardware establishes a practical architecture for AI systems that need to balance performance, privacy, cost, and user experience simultaneously. Every smartphone maker, every personal computing platform, and every enterprise deploying AI-powered applications is going to face the same fundamental trade-offs that Apple has navigated with this partnership, and Apple's solution gives the industry a real and working reference implementation to learn from. The alliance between Apple, Google, and Nvidia is not just a story about three companies deciding to work together. It is a signal about how the AI industry is organizing itself around the hardware capabilities that Nvidia has built, the cloud infrastructure that Google operates, and the device ecosystems that Apple controls, and that organizational reality is going to shape AI development for years to come. The story of Apple joining forces with Google and Nvidia is ultimately a story about the limits of even the most capable and well-resourced technology companies working alone in the era of frontier AI. Apple built the best mobile processor in the world, developed some of the most sophisticated on-device AI capabilities available on any consumer device, and created a cloud AI infrastructure designed from scratch with privacy as the core principle. And despite all of that extraordinary engineering and investment, when it came to deploying the most capable and demanding AI models at the scale and speed that 1 billion users expect, Apple still needed to rely on Nvidia's compute hardware and Google's cloud infrastructure. That is not a failure of Apple's engineering ambition. It is a reflection of how concentrated and specialized the capabilities required for frontier AI have become, and of how comprehensively Nvidia has built the hardware advantage that defines the entire AI industry in 2026. When Apple, the most vertically integrated technology company in the world, becomes a customer of Nvidia's AI chips, it tells you everything you need to know about where real AI compute power lives right now and why that matters for the entire technology industry going forward. The next time you ask Siri something complex, somewhere on a Google server powered by Nvidia's most advanced AI silicon, the answer is being computed on your behalf with the combined engineering efforts of three of the most powerful technology companies in human history working together to get it right.